Hey everybody, it's Mr. Carr again. Today we're looking at Unit 3 and starting with 3.1 Day 1. Okay, so a part of this unit is a lot about triangles. So first thing we're talking about is classifying them. We can classify them by sides or by angles. So by sides, we're looking at a few different things. If there are zero congruent sides, so it looks like this, where it's 1, 2, and 3 like that, nothing matches up. This is called a scalene triangle. I'll write that a little bit neater. Okay, so it's scalene. Now, another thing about scalene triangles is all the angles are also going to be different. So it's zero congruent sides, it's also zero congruent angles. Okay, if we have at least two congruent sides, so like this right here and here, that's going to be called isosceles. If all three sides are congruent, that's going to be an equilateral triangle. Okay. Classifying by angles. If all three angles are acute, so that means all the angles are less than 90 degrees, that makes it an acute triangle. Okay. If you have one right angle, then it's a right triangle. If you have one obtuse angle, it's an obtuse triangle. And if all three angles are congruent angles, then that makes it equiangular. Now, when you do your classification, as long as there's enough information, which almost always there will be, you're going to have one of the answers from here and one from here. So it's going to be a combination of things. So for example, you can have an acute scalene triangle. You can have a right isosceles. Okay. You can have an obtuse scalene. It's one of each. Anytime you're dealing with equilateral, equiangular, though, those always go together. So if you have equilateral, it's definitely equiangular. You cannot have anything that's equiangular, isosceles, things like that. Okay. So we look at some examples of this. One more fact, which will come up in the future as well, but to make a lot of these problems easier, remember all triangles, let me say all triangle angles add to 180 degrees. This is an important piece of information. Okay. So I look at example 1A. Two angles in a triangle have this following measure 60 degrees and 30 degrees. Which descriptions match this triangle? Select all that apply. So when in doubt, draw it out. I'm going to draw a triangle. Doesn't matter what it looks like, but I'm going to make angle F here 30 degrees. Angle R is going to be 60 degrees. So what we need in order to tell us the answer here is we need to find this third angle right here. I'm going to call that X for right now. So the idea is that, again, since all angles or all triangle angles add up to 180 degrees, then I can say that X plus 60 plus 30 is equal to 180. There we go. So that means that adding the 60 and 30 together, I get X plus 90 equals 180. Subtract 90 over, so X is equal to 90. So that means I have a 90-degree angle right here at this corner. Since we have one right angle, then that's a right triangle for sure. Additionally, 30, 60, and 90 are all different angles from each other. So not only do we have a right triangle, we also have a scalene triangle. So I have to pick both of these. Again, it's one of these things by angles, one by sides. So given measure of angle B is 2 times measure of A, and angle A is 40 degrees, classify and sketch a triangle ABC. So just draw out some kind of triangle here. So I'll go with, says here angle B is bigger than angle A. So I'll put A here, B here, and C here. Now, we know that angle A is 40 degrees and angle B is 2 times that. So if I do 2 times 40, I'm going to get 80 degrees. So we have that third angle that we need to figure out. So just like last time, X plus 40 plus 80 is going to equal to 180. So I add these together. So X plus 120 equals 180. Subtract 120, so I get X equals 60. Since all of my angles are different, 40, 60, and 80, okay, so they're all different angles, we know it's going to be scalene. Additionally, all the angles are less than 90 degrees. That makes it acute. So if I put both of these classifications together, I would say it's an acute scalene triangle. Okay. Same thing as the last one. Now we're going to write this out, and based on the description, just draw it as accurately as you can. So angle A and angle B are congruent, and measured angle C is 20 degrees. So I'll just draw a triangle like before. So A, I'll put B over here. And I'll put C here. I did that because I made these look pretty congruent to each other. So this angle is 20 degrees. And if these two are congruent to each other, we'll just call them both X at this point. So that means X plus 20 has to equal to 180. So I combine these together, I get 2x plus 20 equals 180. Subtract 20, I get 2x equals 160. And then I divide by 2, and then x is going to equal to 80. And in this case, it's going to be 80 degrees. So that means it's 80 here and 80 here. Since I have two matching angles, and that makes it isosceles. And I should have mentioned that earlier. I'm going to come back here. We know it's isosceles if we have two sides that match, but if we have two sides match, we also are going to have two angles that are matching. Okay, so two congruent sides, also two congruent angles as well. So that's going to be important as part of that. Okay, so we have two matching angles, we have isosceles. And again, all the angles are less than 90 degrees, so it's acute. So I put these together and describe it completely. It's an acute isosceles. Okay. Next one. Solve for x and then classify the triangle by the sides. Same as before. We actually have everything labeled now. So I know I can do this. I can do 4x plus 6x plus 80 equals 180. Combine these, I get 10x. 10x plus 80 equals 180. I'll subtract 80 over so that 10x is equal to 100. Divide by 10 and I get x equals 10. So from there, I want to find each of these angles. So that means that angle H is equal to 4 times 10, giving me 40 degrees. Angle T is going to be 6 times 10, giving me 60 degrees. So we have 40, 60, and 80. They're all acute and they're all different. So that makes this an acute scalene triangle. Okay, last one we're going to go over together. Let's put this on a coordinate grid. So classify the triangle by its sides. We have A is at 2, 3. Here's point A. B is at 6, 3. So 1, 2, 3, 4, 5, 6. C is at 4, 0, right here. So here's my triangle. Almost looks like it might be equilateral, but we have to confirm that to be on the safe side. Okay, we don't want to assume anything here. So what I'm going to do is I'm going to find each of their lengths. I'm going to start with the easy one. AB is the length from here to here. So I just got to count out the spaces there. It's a horizontal or vertical line. Just count the number of spaces. So I got 1, 2, 3, 4 right there. As for the other ones, you can do Pythagorean theorem or distance formula. So if I want to find this length here for AC, for example, I'll do distance formula for that case. So AC, I'll call this x1, y1, and then x2, y2 here. So when I do that one, I'm going to do 4 minus 2 squared plus 0 minus 3 squared. So that's 4 minus 2 is going to give me 2 squared plus negative 3 squared. It's going to be 4 plus 9. So D is equal to the square root of 13 in this case. So I can write that down like that. It's square root of 13, which is about, I got to pull that up in my calculator again. I want to say 3.6. Yep, or yeah, 3.6. Well, 3.61. When I do this one here, I can do either distance formula or Pythagorean theorem. So in this case, I'll just do Pythagorean theorem just to demonstrate it. So the length here is 2, the length here is 3. And then this is what I'm trying to find is this, I'll call it that D right there. So that means D squared is equal to 2 squared plus 3 squared. It's going to be 4 plus 9. That's going to be 13. So I square root that, and I get the same thing I got earlier. root 13. Just realized I technically mixed those two up. This was all my work for AC. This is my work for BC. There, make sure it matches. So it's about 3.61. Since we have two matching sides with BC and AC, and all I want to do is classify by its sides, then I can just say it's an isosceles. I don't have enough information to say acute or anything like that. So we're just going to go with this one right here. Okay. And that is it for 3.1 day one. So again, we're looking at a certain classification, certain properties of our triangle so far. All right. Keep going with more triangle stuff on later on, but that's it for today. Take care, everyone.